Have you ever wondered why certain items in a supermarket are placed next to each other? Why are the chips often near the soft drinks? Why is the jam near the bread? It's not a random guess. Stores are very interested in what you buy together. This idea is called association. It's like finding a secret connection between different products. When you buy milk, you might also buy cereal. When you buy hot dogs, you probably need hot dog buns. These are simple examples of association. Stores collect a huge amount of data from our shopping baskets every single day, and this data tells a story about how we shop. These connections are everywhere, but they are hidden inside millions of receipts. Imagine a store looking at thousands of customer baskets. Basket 1, bread. Basket 1, milk. Basket 1, eggs. Basket 2, bread. Basket 2, butter. Basket 2, jam. By looking at all these baskets together, the store can start to see patterns. They might notice that when people buy bread, they also tend to buy butter very often. This is a simple but powerful piece of information. It's like discovering two students in a big school are best friends because they are always seen together. Finding these patterns is the goal of something called association rule mining. The mining part means we are digging through a mountain of data to find valuable little nuggets of information. The Apriori algorithm is our detective for finding frequent item sets. An item set is a group of items bought together like bread and milk. The word frequent is key here. We only care about groups that appear often enough. The algorithm works on a simple but brilliant principle called the a priori principle. If an item set is frequent, then all of its subsets must also be frequent. Example: bread, milk, and butter is popular. Bread and milk, bread and butter, milk and butter. Let's walk through it step by step. Basket 1, bread and milk. Basket 2, bread, butter, and jam. Basket 3, milk, butter, and cereal. Basket 4, bread, milk, and butter. Basket 5, bread, milk, and jam. First, count single items. Bread, 4, milk, 4, butter, 3, jam, 2, cereal, 1. Set the minimum count to 3. Remove items below 3, jam. Remove items below 3, cereal. Frequent individual items now. Bread, milk, butter. Make pairs from them. Bread and milk, bread and butter, milk and butter. Count pair occurrences. Bread and milk appears in baskets 1, 4, and 5, 3 times. Bread and butter appears in baskets 2 and 4, 2 times. Milk and butter appears in baskets 3 and 4, 2 times. To decide if a pattern is truly interesting, the a priori algorithm uses 3 important measurements: support, confidence, lift. These metrics help us understand the strength of the connection between items. Let's start with support. Support simply tells us how popular an item set is. It's the fraction of total transactions that contain that specific item set. For our example with 5 transactions, the support for bread and milk would be the number of baskets containing both bread and milk, which is 3, divided by the total number of baskets, which is 5. So, the support for bread and milk is 3 divided by 5, which equals 0.6 or 60%. This means that 60% of all shoppers bought bread and milk together. Next, we have confidence. Confidence measures how likely it is that a customer will buy item B, given that they have already bought item A. It helps us create a directional rule, like if bread, then milk. The formula for the confidence of the rule: if bread leads to milk is the number of transactions with both bread and milk, divided by the number of transactions with just bread. In our example, 3 transactions have both bread and milk, and 4 transactions have bread. So the confidence for bread leading to milk is 3 divided by 4, which equals 0.75 or 75%. This means that 75% of the customers who bought bread also bought milk. This is a strong rule. But what if milk is just a very popular item that everyone buys anyway? That's where our third measurement, lift, comes in. Lift tells us how much more likely a customer is to buy item B when they buy item A, compared to just buying item B on its own. It shows if the 2 items have a real connection or if their frequent appearance together is just a coincidence. The formula is lift equals confidence divided by support for the second item. In our case, confidence for bread leading to milk is 0.75. The support for just milk is the number of baskets with milk, which is 4, divided by the total baskets, which is 5, so that's 0.8. So, Lift for bread leading to milk is 0.75 divided by 0.8, which is 0.9375. After the Apriori algorithm has done its work, the supermarket is left with a list of powerful association rules. These rules are like a treasure map to understanding customer psychology. One of the most common applications is store layout optimization. Supermarkets can physically place associated items close to each other. Pasta sauce are frequently bought together. It makes perfect sense to put them in the same aisle. This makes shopping more convenient for the customer, as they don't have to walk all over the store to find related products. This strategy also works wonders for online shopping. Websites like Amazon are masters of using association rules. Finally, these insights are crucial for marketing and promotions. If a store knows that customers often buy chips, salsa together, they can create a special deal. By understanding the secret connections between products, stores can create smarter deals, arrange their aisles more logically, and provide helpful recommendations, all of which lead to happier customers and a more successful business.